Hello everyone, welcome back to the World of Chemistry YouTube channel. Today we will discuss Millikan's oil drop method. In the class 1 we have studied the structure of atom and discovery of electron. In that discovery of subatomic particles, in that discovery of electron we have studied. So E by M ratio value also we found. So in this class we will discuss Millikan's oil drop method. So what is Millikan oil drop method experiment we will discuss. So I have one question for you. We know electron is negative, but how much negative? What is the charge of one electron? What is the charge of one electron? We can't see electrons. So how did Millikan measure it? So imagine if you want to weight a tiny feather. Okay, you want to weight a tiny feather, but your weighing machine is too big. What will you do? You will hang the feather in air using a fan. If you balance the fan speed so that feather just stays still, not going up, not pulling down, then upward force by fan is equals to downward weight of feather. From that you can find weight, right? So Millikan did the same trick with electrons. So we'll see how the experiment setup goes. Okay. So this is the Millikan's oil drop apparatus. Okay. Here is two plates. Okay. There are two plates. One is positively charged plate. Another is negatively charged plate. Here, this is the one of the box they have taken. In that, two charged plates. One is a positively charged plate and another is a negatively charged plate. They have placed a telescope here, and this is the atomizer. Okay, here we have a oil. Okay, that is spraying oil. So here is a X-ray and current is passing here. Okay, so now why he took oil? He took oil drops, but why? So because the oil doesn't evaporate fast like a water. Because of the evaporation, because of evaporation he took a oil. Water evaporates fastly, but oil doesn't evaporate fast. So he sprayed oil using an atomizer. So this is the atomizer. He sprayed the oil using this atomizer. So here here in the upper positively charged plate, here is a hole. Okay, so he tiny oil drops formed on the positively charged plate. So because of the gravity, like any drop, it falls down. Well, here the hole is created. Because of the gravity, the oil starts flowing down. Now, then he applied electric field over here. Then he applied electric field over here. The two metal plates, one positive top, it is connected to the positive top, and another is connected to the negative of the bottom. So, some oil drops had electrons. Here, some oil drops had electrons. While spraying, due to friction, some drops became charged. Some had one electron, some had two, some had three. But we don't know how to find the charge of one electron because they were having one electron, two electron, or three electron. So what magic happened? Okay, so he adjusted the electric field. He adjusted the electric field at one point. Adjusted the electric field at one point. Okay, at one point the upward electric force balanced to the downward gravity. It is balanced to the downward gravity. So the drop just stopped in mid-air, it floated. So what happened? So it was unable to measure. So what he did, he adjusted it to the electric field at one point. So what happened next? The drop just stopped in the mid here in the air, and it started floated. So now we'll see, if drop is floating, if it is floating, what happens? So upward electric charge, electric force is equal to downward weight of drop. Here I'll write. Okay. What we have to see is upward electric force is equals to downward weight of the drop. That is QE is equals to mg, where Q is a charge on the one drop, Q is the charge on one drop, and E is the electric field, and m is mass of the drop, and g is gravity. So upward electric force is equals to downward weight of drop, that is QE equals to mg, where Q is a charge on drop, E is a electric field, m is a mass of drop, and g is a gravity. Now he found m, that is mass of the drop, by measuring how fast the drop falls without electric field. He knew that E and G. So he calculated Q. He knew the value of E and G, and because of that he calculated Q. So what happened? The result he got is he did this for 1000 drop. Not only for some drops, he did the same repeated experiments for thousands of drops. So the charges were like 1.6 into 10 to the power of minus 19 coulomb. 10 to the power of minus 19 coulomb. Okay. Now every charge was multiple of 1.6 into 10 to the power of minus 19 coulomb. So he said smallest charge possible is the smallest charge possible is 1.6 into 10 to the power of minus 19 coulomb. So this must be the charge of one electron. Okay. So then the Millikan gave us the charge of one electron, that is 1.6 into 10 to the power of minus 19 coulomb. And he proved the charge is quantized. This charge is quantized. The charge is quantized. Means that charge comes in packets. Charge comes in packets. You can have one electron, 2 electron, 3 electron, but not 1.5 electrons. That must be the whole number, not this 1.2.5 like that. Okay. So this is how Millikan drop experiment found the value of 1 electron. After finding the charge of 1 electron, the Millikan, what he did is he combined the uh, he tried to find out the mass of an electron. So what he did is the Thomson's E by M ratio value, he divided charge of the 1 electron by the E by M ratio value, that is 1.602 is a mass of 1 electron, and the E by M ratio is 1.75. So after calculating this, the mass of an electron is 9.1094 into 10 to the power of minus 31 kg. So this is how the Millikan drops method experiment has done. So it is mainly, this experiment mainly done to explain the mass charge of a 1 electron and mass of an electron. So thank you for watching this video. Please subscribe for more concept about related to the chemistry.